Today we're going to be covering 7.1, which is going to eventually go over adjacent and vertical angles. There is some stuff that we have to cover before we get into adjacent and vertical angles, which is what we're going to end up doing today. So by the end of this lesson, you're going to be working on this IXL. You're going to have to get this IXL up to 100 SMART score. So this is going to go all the way up to 100. And that's because you don't even get these questions with measurement of the angle until 70s. So this IXL covers naming angles, measuring angles, and classifying angles, which is the three things that we're covering today. So I'm only going to be giving you this one IXL, but you do have to get it up to a SMART score of 100. Before we get started, you might want to pause this video and go to the Chrome store and find this protractor extension. I'm not sure if you're going to be able to download it on school computers, but it will be useful to have some kind of an overlay to your screen. I'll show you how to use it. So this protractor does look a little different than the protractors that you're used to. These are the ones that you're used to. These only go up to 180 degrees. These protractors on the Chrome extension actually do a full 360. So let's do a little bit of a show and tell on this. So I just pulled up the protractor extension. What I'm going to do is I'm going to get the center right on that vertex, right where that corner is. And then all I'm going to do is drag these ends so they are on each of the sides of my angle. And then it tells me what the measurement is. So you have to use your brain a little bit. This is an acute angle. We'll talk about those words a little bit later. But an acute angle means that it's pretty small. So if I'm looking at these two, I can see that one of them is 65 degrees about, and the other one is about 295. And so if I'm looking at these two, it makes a lot more sense for this small angle to have the smaller number. And so we want to make sure that we're using the correct number when we're using these protractors. So this angle right here for number 4's problem is going to be about 65 degrees. These compasses are really exact, obviously you can tell, but we are humans and we're not going to get it exactly perfect. So you're just going to have to estimate with it, try to get it on the lines best you can, but then just kind of round. So 65 would be my answer for this one, not 65.3. So that's how you use this protractor. We'll get into that in a little bit, but let's get started on our lesson. So our essential question for the day is, what can you conclude about the angles formed by two intersecting lines? And so that's the question that we should be able to answer by the end of this lesson. The first thing we have to do is we have to classify angles. So an acute angle is less than 90 degrees. It is an acute angle. It's small, it's tiny, it is less than 90 degrees. A right angle is exactly 90 degrees. So this is a special case. It has to equal exactly 90 degrees. The way that you show that on the angle is that little kind of square box right there. That little square box tells us that it is exactly 90 degrees, which tells us that this angle is a right angle. Next one is an obtuse angle. An obtuse is greater than 90, so it's bigger than our right angle, but it is less than 180. And so that 180 mark is also a special case of a straight angle. A straight angle is equal to 180 degrees. So it is just, it's literally a straight line, which is how it gets its name, straight angle. So let's practice drawing some angles. So these have tons of different answers. So if your answers don't look like mine, that's totally okay. But I want you to use the description up here to draw the hands on the clocks. So just draw the angles. So pause the video and do that now. So as long as your acute angle is less than 90 degrees, you're good to go. So I'm just going to make mine look like that. And so this, as long as this is the long hand and this is my short hand, would be 3:05. I get 3:05 because the shorthand tells me the hour, and so that's at my 3. And the longhand tells me my minutes. Every time we jump a number, we go up by 5 minutes. And so since it's at the 1, it's going to be 3:05 because it's only gone over 1. So you can take whatever number it's at and multiply it by 5, and that's going to be the minutes. So if it looked like this, that would be 3 because my shorthand's at the 3. And then my longhand's at the 9. 9 times 5 is going to give me 45. And so that would be at 3:45, and that would represent a straight angle. A right angle is going to go left and right. When it's at this noon mark, or when it's at that 12 mark, that means that it's going to be a double 0. So it is exactly 3 o'clock if my longhand is at that 12. And then an obtuse, we'll go shorthands at the 3, longhands at the 10. That would represent 3:50. And as long as you have obtuse angles and right angles, you are correct. These are just my examples. Now I want you to tell me what the exact measures of the angles formed by the clocks of the hands at a given time are. So if we look at this first one together, that 9 o'clock, I'm going to put my small hand at the 9, and my big hand is going up to the 12 because of that double 0. And so that gives me a right angle. I know from before that a right angle is going to be 90 degrees. And so that's going to be my answer to the first one. Go ahead and answer 6 o'clock and noon, or 12. For that 6 o'clock answer, you should have said that that is a 180-degree angle because the shorthand's going down to the 6, longhand's going up to the 12, so it's 180 degrees. It's a straight line. For noon, that means that the longhand is at the 12 and the shorthand is at the 12. So since they're both over top of each other, that's actually going to be at 0 degrees. So now that we've talked about classifying triangles, let's move on to naming angles. So when we name angles, we're just going to go around the angle. And so for example, we've got angle. So we always have this up front. That tells us that it's an angle. BDE. And so we've got a point on one side, we've got the vertex, that corner where the lines meet up, and then we've got the point on the other side. Sometimes angles such as A, like angle A right here, can be named by a single letter. And so sometimes you have this ability to name it by a single letter, like angle A, because it is clear what that angle is. There's only 2 lines coming from that, which means A is going to be our vertice. Angle A is going to be a right angle because there's only 2 lines coming from it and it does form a right angle. Keep in mind that these are both squares. Or if you didn't want to name it angle A, you could always name it angle FAB. Or you could name it BAF because it's going around the shape. So F, A, B. Or the other way, B, A, F. And so that's how we name angles. I want you to get some practice on this, and I want you to name all of the right angles, acute angles, and obtuse angles. So you can either name them with a single point, if you're able to. Obviously, D, it's not going to work, because I don't know if you're talking about E, D, B, or you could be talking about C, D, E, or you could be talking about angle B, C, BDC. And so there's 3 different angle possibilities from that one, whereas angle A, I know it has to be right here. So just for safety purposes, I always use 3 angles because it makes sure that I'm not making a silly mistake. So I always like to do 3 letters. But you are allowed to do 1 letter if you feel confident enough to do so. So go ahead and name all the right angles, all the acute angles, and all the obtuse angles in this shape right here. Pause the screen and do that now. These are all the angles that I found. Maybe you found more than I did. So see if yours is on the list. If your thought is not on the list, it doesn't mean you're wrong. I just might have missed it. So these are all the ones I found for right angles. These are all the ones I found for acute angles. And I only found 1 obtuse angle, which is going to be right there. So if you found more than me, because that was the only one I found, let me know. Okay, so which pairs of angles do you think are adjacent, and explain? So I am going to help you out with this question because we haven't really talked too much about adjacent and vertical angles. Adjacent means that they are right next to each other. So for example, Indiana and Ohio are adjacent shapes because they share a border. So if I'm looking, which ones might be adjacent angles? Hint, they're going to share a side. So pick 2 angles that are adjacent and explain why they're adjacent. Pause the video and try that now. For my example, I'm going to pick angle, angle ABE and angle EBD. And so these 2 angles are adjacent because they share that side. They have that side in common. And so that's my explanation on it and my 2 adjacent angles that I picked. All right, so our third activity is going to be measuring angles. So if we're looking at this street right here, how many angles are formed by intersecting roads? Number the angles. So for this, what I mean by number the angles is this is going to be angle 1. This is going to be angle 2, angle 3, and lastly, angle 4. So we've got 4 different angles, and we've numbered them. Now I want you to measure each angle formed by the intersecting roads. So we've got angle 1, angle 2, angle 3, and angle 4. Let's go ahead and pull up that tool and measure these angles. So again, I'm going to put it right on that intersection, best I can. And angle 1 is right about there. And so if we're looking at this, it's kind of hard for me to read that. It says about 111. Let's write that down. Angle 1 is 111. Let's check out angle 2. Back in the middle. And then we're right. And so that is about a 70-degree angle. So angle 2 is about 70 degrees. Angle 3 is over here. Let's see. That one we can say is about 109-ish from our measurements. And then angle 2 is about 70. And so we've measured these 4 angles And these are what we got. And so our question is, what do you notice? So what do you notice about these angles? Hopefully you're noticing that the angles that are across from each other, so angle 1 and angle 3, have about the same measurement. And angles 2 and 4, which are across from each other, have what we found is exactly the same measurement. And there's a reason for that. It's because these angles are vertical angles. And so that is our second vocabulary word. And vertical angles are actually the same size. And so we got the same angle for these two, which is good. That's what we were supposed to get. But again, like I was talking about before, when we measure things, we're not going to be exactly perfect with our measuring. So even though these are not the same number, they're close enough because they should be the same number. And so that's just measuring our angles. I've got two last questions for you before you start your homework. First one is, in your own words, what can you conclude about the angles formed by two intersecting lines? So that goes back to our essential question of what can you conclude about the angles formed by two intersecting lines? So it's just going through and answering that essential question and putting what we learned today in your own words. And then I want you to draw two acute angles that are adjacent. Remember, adjacent means that they're next to each other, like Indiana and Ohio. So go ahead and try to answer these two questions. Pause the video, try them out. So with this first one, number 4, what can you conclude about the angles formed by two intersecting lines? Basically, whatever you wrote from today's lesson is going to be accurate. The big conclusion is, how to name them, how to measure them, and how to classify them. So as long as you know those, you are good to go from today's lesson. And then drawing two acute angles that are adjacent. So we've got one acute angle, it's tiny. We've got our second acute angle, it's tiny. And so that would be two acute angles that are adjacent. So whatever it looks like, as long as it's less than 90 degrees and these angles are sharing a side, it is okay. You can have a really small angle and a kind of bigger angle, as long as it's less than 90 for that second angle. You're good to go. If you have any questions, send me an email.